Hello friends, in this session we're going to see some other use of lambda expressions, and in the previous session we have seen some use of lambda expression, how to write a lambda expression and without argumented lambda expression, or argumented or multiple argumented, and return type and all these things, right? So here we're going to see some other use of lambda expression. Say I have so when you are developing a thread by using runnable interface, normally what you do is, say you write a class by say my thread by implementing runnable interface, right? And you have to override the run method here, and so this is, sorry, it should be runnable interface, and you should override the run method of this. And inside the run methods I am giving the implementation something like this. You get the current thread and current thread. Write a for loop in this, say int I is equal to 0, I less than 10, and I plus plus, right? And in this, say I'll have a SOP statement. It should print the I value plus one tab space plus thread name, right? And the thread has to sleep for, say, try and catch, and exception E, and I'll just print the stack here, right? And the thread should sleep for, say, for thread.sleep for 500 milliseconds, right? And now to develop a thread by using this runnable object, first you have to create a myThread object. My thread is equal to new myThread, and it is not actually a thread object, so by using this thread th is equal to new thread by giving the runnable interface object, right? And now you can say th dot start, and thread is starting, right? So just run this and see the output once, right? It is thread 0 and executing like this, so this should run 10 times. So this is over. Now instead of here, what we are doing, we have declared a runnable interface, and we have declared a class by implementing runnable interface, and in runnable interface we have implemented the method here, and this is this object of this myThread we have passed into the thread constructor, created the thread, and the thread is started, right? So if you don't want to take this extra class here, say, then you can go with the anonymous in a class, and in that case you have to do, this is myThread, or you say it is, say, thread th1 is new thread, and here only you give a new runnable interface class, right? So this is becoming an anonymous class in this, right? So give the anonymous class here, and till this, right, till this, right? So in that again you give the same implementation, say thread th is thread, and get the current thread, give a for loop int I is equal to 0, I less than 10, and some I plus plus. In that it should print I plus one tab space and plus thread dot get name I need to print, right? And thread also should go to sleep state for some time, so it is exception E, and just print the stack, right? And now here we can say it is thread dot sleep for, say, 500 milliseconds, right? So this is the anonymous class till this, right? till this is the anonymous class object, and you are supplying it as a thread and to create the thread object. Instead of declaring a separate class, you can do it like this, and then finally here you have to say th1.start, right? And the thread is going to start. Run it and check the output. So here thread 1 and thread 2, two thread is running at a time actually. So I'll just put this part in comment first. I'll not start this thread, and currently this thread 1 only should run it, and thread 1 is running, and it is this one. Or you can give another message also along with this. Here you can say plus 1 tab space, and this is from anonymous in a class, right, for better understanding, and you can run it now, and it is from anonymous in a class. 10 times thread is running. And for the same, if you want for the previous one, then here you can give it, so this is from 1 tab space, and you can say this is from a subclass. This is from a subclass. Run it. Okay, I have not started, I think. Start. And now run. This is fine. One is from the subclass and one is from the anonymous inner class, right? So two thread is running. So before to the lambda expression, you have to use any one of these two approach. Either you have to take a subclass of the runnable interface, and that object you have to supply inside the thread constructor to create the object, or you have to take a runnable, you have to take an anonymous inner class for this thread object, and you have to supply it here. Now after the lambda expression, now if I apply lambda expression at this point, and then how it will be, instead of this runnable interface, because runnable is also an interface, and you can create a lambda expression for this, and it is having only one method also. So now to apply the lambda expression, you can say first I will take a runnable interface here. So this is runnable r, and runnable is equal to u. This is the expression, right? And this. So this is the lambda expression of runnable interface. Till this is the lambda expression, right? So whatever implementation we did before, that I have to do here. Say it is thread th is equal to thread, and get the current thread, and you run a for loop, because thread is local variable here, so it will say it is c thread, current thread, and run a for loop here. Int I is equal to 0, I less than 10, and I plus plus, and in that you print I value plus 1 tab space plus th dot get name, and plus you write here it is another tab space, it is from now lambda expression, and again the thread also should go to a sleep state. So this is thread, or you have to put that in try and catch, actually try and take a catch exception e, and print the trace the stack here, right? And the thread should go to, this is thread dot sleep for 500 milliseconds, right? So it is 500 milliseconds. So this is the lambda expression. Now instead of declaring a separate class, now directly you are taking this as lambda expression is still this, right? And this is the implementation. This is the implementation of run method you are giving here. Implementation of run method. Okay, this is the implementation of run method. Now this runnable reference variable stores the implementation of run method instead of taking an object of type runnable. Now by using this, you can say here thread th is equal to, or th is already there, so it is thread 5 new thread of runnable, right? And you can say th5 dot start, right? Now you run it. This is from lambda expression. 3 thread is running now, thread 0, thread 1, and thread thread sub thread 0 and thread 1. Again, this is also thread. It is not thread, actually it is current thread dot get name, right? Now run it. It is thread 2 from Lambda expression, right? So this is by using Lambda expression, but this Lambda expression we are not supplying in this as an parameter, right? We have created a Lambda expression first, and that I have stored into a runnable reference variable, and that we are supplying here. Now the same operation if I do by using Lambda expression as an parameter. So what you will do is thread th, say it is 6, new thread, and here you have to give the Lambda expression. So Lambda expression how will you give here is this and this and this, done, right? So this is the Lambda expression you have to supply here like this, but it is not this, right? So this is Lambda expression. So inside this Lambda expression now you have to give the implementation of your thread. So here the implementation is the same implementation. You can just copy and put it here. Just copy this and you can put at this point. Right, it is this, right? So now the Lambda expression is from here, it is still, this is the Lambda expression. So this is current thread again you are getting, and this is thread 6, okay, current thread you are getting, and running a for loop again, and you are doing the same thing what it did before. But now here I'll give a message different, say lambda from Lambda expression, but it is as parameter, right? Lambda expression parameter. Now you got the thread 6 and thread 6 dot start, run it, it is fine. Lambda expression is parameter, right? And okay, this is Lambda expression as parameter. So this is how you can use Lambda expression to create a thread object. So two you have seen here. This is Lambda expression as a parameter in this thread constructor we are using to create the thread object, or Lambda expression we have created first here, and then I have supplied that here to create the thread object, right? Anyone you can use. Next one is, suppose you have a, I'll take one more example. So it is test2 in this package, test2, and in this test we have a list, suppose, or yeah, I have a array list, array list. We have an array list, and this is of type string, suppose, and it has to say a list is equal to new array list, right? And in that we have some elements. So list dot add of add some strings, say it is Java, list dot add say servlets, and list dot add some JDBC, list dot add of, so this is JSP, and list dot add, say it is XML, and list dot add some HTML, something, right? Some elements we have, and we are printing here this is a list. So it is going to give you the output of the list, and run it. These are the outputs, right? And the element in which order you have stored, it is printing in the same order. Now I want to sort that element, right? I want to sort this element inside the list. Then what you can do, you have a method in collections class, so you can say collections dot sort method by giving the list which one you want to sort, it is list, and you have to give here a comparator interface, right? You have to give here a comparator interface. So the comparator interface, you have to develop the comparator first and then you can supply here, right? So a comparator, take a class, say my comparator implements comparator, and I'll generalize here it is string type, right? And in this comparator I'll take you have a method compare is the method which is taking to argument string type both, and cell it is s1, and you can say here it is s2, right? Now in this you can say return s1 dot compare to s2, right? Now this object you have to supply inside this, so I can say here new my comparator. That's it, done, right? And this function is going to sort your list. And now if I print here the list, so it is list, and run this, it is fine in sorted order. If I want that in descending order, that what you can do, this is just here is the change, that is s2 and this is s1. Now you get the element in descending order, right? So the elements are in descending order. So instead of doing this, if I don't want like this a separate class for comparator, again you can go with a anonymous class and you can do it like this. So collections dot sort, and list is this list only, and for the comparator you can give here a anonymous class, a new comparator, and this creates the class here, and here you can apply the generics. So this is string type, and this is the comparator. In that you have to override the compare to method, compare to, and in this, say this is again s1 and this is s2, and it has to return s1 compared to s2, right? So this is anonymous in a class. From here till this anonymous in a class object is created, and that is supplied to the sort function. Instead of creating a class separately and here you are supplying the object, you have created a anonymous class, and an anonymous class object is created, and that object is supplied at this place. Now after that, if I print here collection, or you just print list, right? Here we have already sorted, that is in descending order, but in this again we are sorting, that is in ascending order, and run it, it is now in ascending order, right? So this is, first one is by using comparator as a separate class, and here you are using comparator as anonymous in a class. Now the same if we do by using one lambda expression. So draw another line and take a lambda expression for runnable interface. So this is, sorry, not runnable, comparator, and generalized type string, and I'm giving here com is equal to this. But this function you are implementing here is compare function, and compare function is having two arguments. So you have to give here argument is of type string, data type I will not mention, it's just s1 and s2, and in this you have to give the implementation I am giving here return s1 compared to s2, right? This, but this is already in ascending order here, so again I will do it in descending order. So this is s2 and this is s1, right? So this is a lambda expression created now, and this lambda expression is stored into this com, right? Is stored into this com. So this is the lambda expression, and now if I do it, say, or in this case you have only one statement, so I will not use this also, and I'll just write this, and even you don't need the return also, this is also not required, right? So this is the lambda expression, very simple. You can just use this, and you can say collections dot sort of this list and by using com, right? So it is very simple. This is just the expression and you are supplying the expression. So here you are going to get in, and again it is in descending order, right? Run it. This is again, or I have not printed actually, so print list again, run this, and it is printing again in descending order. Next again, instead of creating a lambda expression separately, storing into this com, and you are supplying it here, here only you can create the lambda expression. So I can write it again, and it is this. So collections dot directly collections dot sort of list, and you have to give the implementation. This is s1, and or you take it like this first, and in this you have this one and two argument s1 and s2, and you have to give s1 compared to s2, right? That's it. And this is termination is not required, so that's it. So this is the lambda expression you are supplying. Now first argument is the list, and the lambda expression you are supplying directly to the collection dot sort function, and after that you can just print here it is list. Run this. So this is again done, right? So first one, when you did, it was this is the collection, and when you are sorting it, you are giving here a my comparator, and for this my comparator you have created a separate class here, and that object is supplied. Then instead of writing a separate class, we have used anonymous in a class, and we have used here anonymous in a class. Then the next one, we have used a lambda expression, but this lambda expression was not supplied as a parameter. We have stored into this com, and then we have given that to this sort function. But now we have supplied that here as a parameter, right? This is a parameter. It is supplied like this. So this is the lambda expression we have used, and this lambda expression we have used, assume it is a comparator which was already ready and that we have used in this. But assume I have a set of type student, and this is set, and I have a new tree set. I have a tree set, and in tree set we are going to store the element of type student, right? And you already know that tree set stores the element in sorted order. So the element which you are going to store into tree set should be of type comparable, otherwise this gives a problem. Or if the elements are not comparable, then here you have to give a comparator object. So I have a class here student, and it is having int type sid and a string type name, and take a constructor here to initialize these two, student int sid and the string type name, and it is this dot sid is sid and this dot name is name, right? Now I'll override the toString method also, toString, and toString should print return sid plus one tab space plus name, right? This should be the output of toString. Now in this, when I'll store the student object, first if I say set.add of new student of say 101, or it is 101 and some name is abc, one student. Set.add again another student, new student of some 99 and the name is some xyz, and again set dot add some other student, say new student, and this is some say 200, and the name is some Kishore. Another student, set dot add new student, and it is say 10, and the name is Pankaj, right, some students. And if I print here set, I'm trying to store these elements into a tree set, but the tree set is going to store the elements in sorted order, so the elements which you are storing in that should be of type comparable. But if the elements are not comparable, means if the student class is not implementing comparable interface, then what you have to do is you have to write a comparator for that, and that you have to supply here. Otherwise you're going to get a exception, right? A runtime exception you're going to get. Here it is class cast exception for this. You're getting a class cast exception. So now what you have to do is, say this student class is not having comparable, you have to write a comparator for this. So I'll write a class student, or I'll just say SID comparator implements comparator, and it is generalized of type student. Now in this, when you'll override compare to function, compare to, and I'll say this is student 1, and this is student 2, and it is to return an integer value, the difference. So I'll say s1.sid minus s2.sid, right? And this object, comparator object, you have to supply here. It is new SID comparator, right? New SID comparator. Now it is fine. Based on the student ID, the elements are going to be sorted. Run it. It is sorting based on the SID. First is 10, and this is 99, 101, and it is 200. The elements are sorted in ascending order based on the student SID, right? And it is using this comparator to do that. Now instead of writing this comparator again, you can take anonymous in a class. So I'll take another set. Suppose I have one more. So this is set 1, and in set 1, this is set 1, one student rated, set 2 another student, and set 3, it is 1 only, and it is 1, and it is 1, right? Some students rated, and set 1 I am printing. Now the comparator, I don't want this, I want, instead of that, I want a anonymous class. So you can say new comparator of generics type, it is student, right? Student. Now inside this new student, and here you have to override the compare function. New comparator, and you have to override here the compare function, and again inside this function, this is s1 and this is s2, and assume I want here in descending order. So what I can do is return s2.sid is minus s1.sid, right? Now this is done. And instead of using a separate class, here only I am using a anonymous class, and I am doing this. Now you run it, it is fine, it is in descending order, right? Now instead of using again the anonymous class, we can use a lambda expression for this in the same way. So I'll take here one more. So this is set 2, and elements are stored here. This is set 2, and this is 2, right? And 2 is printed. Now instead of using this, I don't want to use this, I want to use a lambda expression for this. So you write a lambda expression here, comparator, student type, and say this is as comparator, and you can write it here, and it has two arguments, so s1 and s2, but that s1 and s2 is of, it should have a return value, so I'll not take the blocks. I'll just say s1 dot sid minus s2 dot sid, right? So this is the lambda expression in one line. It is very simple. So you can write here simply it is as comparator, and run it, and we have given here it is in ascending order. Now run it, it is in ascending order, right? So now again I'll take one more set, and there I'll pass lambda expression as a parameter. So this is not required, and we have set 3, and this is 3, this is 3, and this is 3 and 3, right? Now instead of supplying this here, you can just write a lambda expression at that point. So lambda expression is having s1 and s2, and it should have this s1, or I'll write in reverse order, s2 minus s1. That's it, right? This is the lambda expression. Sorry, s2 dot sid and s1 dot sid. Right, so this is again very simple, just lambda expression is this. You don't need to write any class or anonymous class or anything, and you just print here s3. Run it, it is fine, right? Fine. So this is some use of lambda expression, how many ways you can use. We have practiced some ways here, and in the next session we're going to see the functional interface. So thanks for watching my videos. Please subscribe for more.